Alright, so we learned the law of sines, and now we're going to look at the law of cosines. And so this is the second relationship between oblique triangles. And so you're going to use the law of cosines to solve side angle side triangles or side 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 triangles. And so the way that you'll know, because a lot of times on the exam they're not going to say specifically solve this triangle by using the law of sines or solve this triangle by using the law of cosines. They're just going to say solve the triangle. And you're going to have to know which one you need to use. And so the way that you'll know that you need to use the law of cosines is if you are not given a pair. Remember, in the law of sines, you were always given a pair to start out with. And so, or you were able to find a pair. For example, right here, you weren't necessarily given a pair, but you could use these other two angles to find this angle, and then you would have a pair. But now in the law of cosines, it's different. There's no way that you're going to be able to ever get a pair, or you're not given a pair. Okay, especially in a side, side, side. There's no way that you can do that. And so that's how you're going to know when to use the law of cosines, is if you're not given a pair. And so we're going to look at an example of each of these kinds of triangles. And so here is the law of cosines. The good thing is, as far as I know, you'll be given this on the exam, so it's not something that you have to memorize. But each one of these three are basically the same formula with just different letters in different places. It just depends on what you're trying to solve for, which one you're going to use. And I'll show you an easy way to remember which one you're going to use. Alright, so we're going to look at this first example. And the only thing about using the law of cosines is it's kind of a pain because you have to remember these steps when you're finding or using the law of cosines. And the steps from the book are a lot more complicated than they really need to be. I'm just going to write out to the side what they're actually saying in a lot easier terms. Alright, so here is our sine angle side triangle. Now the first thing you're going to do is, if you're given a side angle side triangle, you've only got one side that's missing. So the first thing you're going to do is use the law of cosines basically to find the missing side. Okay, so you're just going to use the law of cosines to find the missing side. And the missing side is just going to tell you which one of those formulas to use also. So the only side that we're missing in this triangle is side A. And so that means I'm going to use this A formula right here. I'm missing side A, so I'm going to use A to find it. So I'm going to write this formula down and go find that first. So A squared equals B squared plus C squared minus 2BC cosine A. Let me make sure that's right. BC minus 2BC cos A. Alright, so that's correct. So then I'm just going to plug in everything to this formula and figure out what A is. So A squared is going to equal B squared. B goes with this side right here, so that's just going to be 20 squared. Plus C is going to be 30 squared. Minus 2 times 20 times 30. I'm just plugging those values in. And then cosine of angle A. Anytime we've got a capital letter or it's inside a trig function, that's an angle. So this is going to be angle 60. Now, they gave me that angle in degrees, so when I go use my calculator to figure out what this is, I need to make sure my calculator's in degrees. And I've already checked mine, and it is. But when I type this in, I'm going to type it in just like it is. So 20 squared plus 30 squared minus 2 times 20 times 30. And then cosine of 60. And so when I do that, that's going to end up giving me 700. So I get A squared equals 700. So to solve for that, I'm going to take the square root, and that'll give me A equals the square root of 700. Okay, and I did not put plus or minus in front of this because there's really no way that I could have a leg or a length of a side of the triangle that is a negative value. So I'm just going to leave it positive, square root of 700. And I'm going to go find what that is. And so I'm just going to round that to 26.5. So I want you to round these most of the time to just one decimal place. So 26.5, this is inches. Now, since I found 26.5, that gives me a pair. So now I've got side A and angle A. So the second step is to use the law of sines to find the angle opposite of the shorter leg. So basically you're going to find the smallest angle next. And the way that you're going to know what the smallest angle is by looking at what's the smallest leg. The smallest angle is going to go with the smallest leg. So that's going to be angle B that we need to find. So I'm going to set my law of sines up. This is going to be 20 over, I know I'm trying to find angle B. So that's just going to be sine of B. Equals, now I've got a pair. And in my problem, I'm going to write 26.5 over the sine of 60. But in my calculator, if I round this value, it's going to throw this angle off a little bit. So in my calculator, what I like to do is use this little store feature. So I'm going to store this, all these decimals that I got for the square root of 700, I'm going to store that for x. And so what that does is now anytime I hit x, it knows that it's really just 26 point all those decimals, and it stores them all for me. And so when I go to solve this law of sines, I'm going to solve it just like normal. This is 20 sine 60 equals 26.5 sine B. Now to solve this, I can't just divide by 26.5 sine. I've got to first get rid of this number right here, 26.5. So when I type this in my calculator, I'm going to type in 20 sine 60. And then I'm going to divide that by x. And so then that gives me this small decimal. And so that's what the sine is going to equal. So I've got the sine of this angle equals 0.65. I'm just going to round to 0.65. And so the way that I get rid of sine is not by dividing, but by taking the sine inverse of this 0.65. So I'm going to take in my calculator like this, the sine inverse of this answer. And again, I don't want to cut the decimals off, so I'm going to hit second answer so it stores them all. And then hit enter. And so then that tells me that this angle is about 40.1 degrees. So angle B is about 40.1. And so then the third step is just to find the third angle the normal way. And I already reworded that. So the normal way would just be to subtract, and that should be 40.9, not 40.1. But it would just be to add these up and subtract them from 180. So if we add those up, so 60 plus 40.9, and then subtract 180, or subtract that from 180, then that's just going to give me 79.1 degrees. And so then I've solved my triangle. Now, the second kind of triangle that we're going to look at is a side, side, side. And so the side, side, side has its own set of steps too. And so I'm just going to reword these two as we go. But it says use the law of cosines to find the angle opposite the longest leg. So basically, you're going to find the biggest angle first. And this should be find, not find. But so we're going to find biggest angle first. Alright, so the biggest angle is going to go with the biggest leg, and it's not always drawn to scale, so you need to look at what the biggest leg is. And so that's just going to be angle B. And so then that tells me that I'm going to use this B squared equals formula. So B squared equals A squared plus C squared minus 2AC cosine big B. Now I'm going to plug in everything I know. I'm looking for an angle, so what I know is that B is going to be 9 squared equals 6 squared plus 4 squared minus 2 times 6 times 4, and then cosine of big B. Now, I'm going to go ahead and combine and simplify what I can. 9 squared I know is going to be 81. 6 squared plus 4 squared, that's going to be 36 plus 16, which gives me 52, minus 2 times 6 times 4 is just going to be 48, cosine of B. So now that I've simplified that, I'm going to show you a mistake that a ton of people make, and so don't make it. If you have this, let's say I've got 5 equals 2 minus 3x. I would not go ahead and combine these and say this is 5 equals negative x. No. You can't do that. Okay, it's the same way down here. This 48 is attached to the cosine B, so you cannot go ahead and say 52 minus 48. That will not work, and a ton of people do that, and you will get it wrong every time. So make sure that at this point you solve it like you would this equation. And so we would solve this equation by subtracting 2 over. So I'm going to subtract 52 over. 81 minus 52 is just going to be 29. And so 29 equals negative 48 cosine B. Now to solve, I'm going to divide. So this would be a negative 29 over 48 equals my cosine B. And so to solve, I'm going to take the cosine inverse of that. And so the cosine inverse of negative, that was negative 29 over 48. That's just going to be 127.2 degrees. And so I'm going to round that to 127.2 degrees. All right, that's my first step. Now my second step, this should be fine too, but my second step is to basically find the smallest angle second. So we found the biggest angle first. Now you need to find smallest angle second. Alright, so the smallest angle is going to be C, angle C. And so I'm going to use the law of sines to solve that, just because I've got a pair now and I think that's a little easier. But the law of sines, when I do that, I'm going to set up this 9 over the sine of 127.2 equals, I'm finding side C, or angle C, so I'm going to put 4 over the sine of C. Now, when I plug this in, remember this 127.2 is what I've rounded. I'm going to store that value for x so I don't lose the decimals. And so when I solve this, I'm just going to have 4 times the sine of 127.2 equals 9 sine C. And so at this point, you can just solve it on the calculator if you want to. I'm going to type in 4 sine x. So 4 sine, I stored that value for x. So that's that. I'm going to divide by 9. So divide by 9. And then of this, I'm going to take the sine inverse. So the sine inverse of that answer is just going to be 20.7. So that means this angle is 20.7. And so then we can easily find the other angle. If I add those two together, that's going to be 147.9. So I'm going to take 180 and subtract 147.9. And that would give me that this is 32.1 degrees. And so then my triangle is solved.